Okay guys, so we are continuing the second part of the video, lecture 13, which is kinematics. So this time I will explain about the example 2. Okay, so sorry because I have to explain faster, very quickly. Okay, so example 2. The previous example showing only one single rigid body. Okay, but this example is showing you the two different rigid bodies. Okay, so it is having more complex calculation. Okay, more complex and more unknown value, and of course if you have more unknown value, then you have to construct more equation. Okay, as I mentioned, if you have two unknowns, then you have to construct two equation. If you have four unknowns, then you have to construct four equation at least. So this is the example 2. Okay, again you have to understand the blocks or the diagram or the picture, and also the given information there, and then you have to identify what is the available input or available information from the question, and also you have to understand what you are trying to find, what you are trying to solve the problem. So from this example, you have to determine acceleration of block A and B. Okay, so this is the two. So you have to find AA and also find AB. Okay, and then the tension. Okay, so tension, let's say we have a tension at A. Okay, and then a tension at B. The instant the system is released from the rest at the position shown, all surfaces of contact are smooth. So this one smooth means that there is no friction. Frictionless. Okay, frictionless. So the mu will be always 0. So this is the information that you have to understand, and other information is the weight. This one is 1 kg, this one is 2 kg. Okay, so this is the available information. Okay, what you have to do, the first thing is FBD. Okay, FBD. So I will skip my my drawing because I want to make it faster. All right, so the drawing should be having at least 2. So the first drawing is for the block A. Okay, so block A, FBD, and the second drawing is for the block D. Okay, so there are two different free body diagram, and of course if you have this equation, so you have another free body diagram, the force or the kinematics one, the FBD one, and MA is the movement one. Okay, right, so this is an example of the FBD. Okay, so before that you have to assume the direction of the movement first. Okay, if the example 1 is very straightforward here, we can assume this rigid body will be moving this way, we moving upwards through the inclination floor. Okay, so this one will be having A at this direction, so A is given there. Okay, so if this body, okay, sorry, if this body, then the same thing that you have to assume, where you have to put the direction or the movement of these two rigid body. So if you are in the class, physical class, I will ask either this direction or this direction. So because this one is pre-recorded video, then I only can ask the laptop only lah. So laptop cannot answer my question. Okay, so I will only can give the answer lah, of course. So number 2 or number 1, or number 1 or number 2? Which one? Think. I give you 1 minute to think. Laptop. Hi Siri. You have to think 1 minute. Within 1 minute, which direction? Number 1 or number 2? Okay, 1 minute. 1 minute. 1 minute. Think. So let's think. So you have to determine. This one is number 2 as well lah. This one is number 1. So which direction? With movement. Okay. So you have to set early. It is not actually, the answer will be same if you put number 1 and number 2. Both are correct. In the end of the day, the difference is only the direction. The magnitude will be same always. Okay. Okay, let's say I choose number 2. Let's say I choose number 2. So this rigid body will be moving like this way. Okay, this rigid body will be moving like this way. Okay, so if moving like this way, you have to make sure that your acceleration is this way as well. Okay, alright. So go back to the FBD. So let's say I put this way, like I mentioned to you, this way. Okay, I mentioned to you, this one is the first FBD, the second FBD. Okay, and this is the direction for acceleration. Okay, and then for the first FBD, of course you have to determine everything lah. Okay, you detach A from the other sources, from the other external parts, and then from here you have to determine the external forces, you have to determine the internal, you have to determine the normal. Okay, you have to determine the friction we have. This direction is the force. So again, there is no friction, okay, which is mu equal to 0. So df is equal to 0. Okay, so that's why in our FBD there is no friction force. We only have a normal force. Okay, a normal force. Okay, once you have this FBD, okay, you can solve it. And of course, if you have to determine the axis, okay, let me erase this one first. Let's say you want to determine the axis, it's up to you as well. Okay, it's up to you as well. Either you want to have this axis or this axis following this inclination. Okay, it's up to you. And same goes this one. So you can determine like this one as well. Okay, this one is for this one, this angle for this one, sorry. Or maybe you can use this axis. So this one is up to us, and at the end of the day, the answer will be same. So this definition, you have to make sure that this definition is actually depending on us. Okay, you have to set earlier on, this is the assumption, this is the definition. Okay, maybe the assumption from yours is not similar with the others. Okay, but if you have this different definition, again, in the end of the day, the answer will be similar in terms of the magnitude. Okay, so go back to the FBD. Yeah, so once you have this one, what the thing that you have to do is, of course, resolve lah. From the FBD, you have to resolve into the several components. Okay, so TA is already following this axis, X and Y. Okay, so this one is different, X and Y. Okay, it's up to you. It's up to you. Okay, and then this one should be resolved into, okay, we have this cos 45. Okay, right, and then you have this one. sine 45. Okay. Okay. So this one is only x component. So y component is no longer available here. So in this solution is for the x analysis for the first FBD. Okay, so you no need to find y analysis because it will be equal to 0. Okay, and the second FBD, so this one is only x analysis, so y will be always 0. Okay, so this one is x analysis only. Okay, so x analysis, you only have to resolve this component lah, which is 2 times 9.81 sine 30. Okay, and then everything there you can put this one is because negative, this one following the assumption. Okay, so this one is following the assumption here. Okay, and of course 2 is the mass lah. Okay, and the end of the day you will get the two different equation, equation 1 and equation 2. So if you can see here, from here you have 1, 2, 3, 4 unknowns, as I mentioned to you here. So 4 unknowns. So if you have 4 unknowns, then you have to develop at least 4 different equation. So where to find another 2 equation? So the equation can be from the displacement, okay, that you learn in kinematics, or the equation can be from the tension itself, coming from the pulley system. Okay, so because we have a pulley system here, so you can develop the equation from the pulley system. So another equation is coming from the pulley system. So this one is, you still remember, okay, where the TA will be similar to the another TA if the cable is similar. So this one is TA. So going through this one should be TA as well. This one should be TA as well. So you will have 2 more equations, okay, from the other views. And then this one is of course TB lah. Okay, so this TB. Okay, so why TB there? We assume that this is a tension as well. This one is tension, even though it's not a cable, but somehow we have the reaction of action. Okay, you have to remember reaction and action. At this point that I make it a larger circle here, this one is reaction or action. So reaction should be tension lah here. Okay, tension for TB. So from here you will get another equation, which is equation number 3. So where is another one equation number 4? So equation number 4, okay, it is coming from the displacement. So displacement, let me erase this one first. Okay, displacement, oops. So displacement, okay, if you can understand the displacement, if let's say you are thinking this is the acceleration, okay, displacement is the cable itself, okay, the cable itself, where it's starting from here. So this is the displacement, okay, this displacement as well. So let's say I put SA here, SB, okay, of course the original displacement lah, I mean the original position or the starting position of this displacement Okay, and then let's say I put in this one is C, so the rest cable should be SC lah. Okay, so the total length cable, or if you still remember total distance, okay, travel, okay, just similar like in this case total cable. So total cable, you can see we have the total cable here, this one which is AC, okay, this one which is SC, I put number 2, this one should be SB, this one same lah, SB, or number 3, okay. So total cable will be SE plus SC plus 2SB. This one you learn it in the total distance travel before. Okay, and then this is the equation that you will develop. Sorry, okay. So this one is the total length, okay, the total cable, okay. SA is the variable length, which is it varies, okay, and B is the variable length, which is varies as well, but the length of rest of the cable will be constant, will be similar. Okay, you have to understand that SA node is not equal to SA final, so that's why we put variable. And SB node is not equal to SP. Okay, that's why we put variable. But SC, the rest will be always similar. Will be always similar. So there is no variable in this situation. Okay. So I erase everything here. Okay, and then so if you still remember, in a rectilinear motion, we can get the A or V coming from the displacement by differentiating. Okay, so you have to differentiate the S, and then you will get the V. Okay, this one, ds over dt. So you will get V equal to V. Okay, and then once you have V, you can differentiate V, you will get the acceleration, okay, which is here. So total length is the constant, not variable, constant. Variable means that we do have maybe an unknown value, okay, or the if you still remember, we do have the parabolic equation like this one, plus bx plus c. Okay, c we can represent it constant like this one. Okay, and then if you a bit messy here, let me erase the other things. It's a bit messy. Okay, again I will differentiate. Okay, if I differentiate this one, okay, I will get velocity. Okay, and if I differentiate the velocity, I will get acceleration. So once you rearrange, then you will get the another equation, which is equation number 4. Okay, and the negative sign indicates that the motion of block A is reverse. Okay, this one you need to understand, and also you need to, what we call it, you have to imagine why this negative value is appear. Okay, because it is reverse. Okay, it is a reverse block, is reverse. Okay, reverse means that, okay, reverse means that, so it will be reverse like this one lah, going down lah. Okay, Okay, so solution. Once you have the 4 equation with 4 different unknowns, okay, you can solve it. So the first one, you can input this equation, the third equation, okay, and this equation, the fourth equation, into equation number 2. Okay, here, equation number 2. Okay, and then you will construct another equation, which is equation number 5. Okay, so from this equation, you have the same unknown, which is TA and TA, sorry, AA and AA. Okay, equation number 1 is also having TA and AA. Equation number 5, we have AA and TA. So you solve these two equations by deduction, or okay, and then you will get the TA, and then you import TA into third equation, which is this third equation. Okay, third, you will get TB. Okay, and then the TA again import into 1. Okay, import into 1, you will get the acceleration, and import A into fourth equation. Okay, fourth equation here, you will get the AB. Okay, so 45 degrees is given, 35 degrees is given as well, okay, from the question here. So this is the final answer for the problem. Okay, you have the TA, you have the TB, and also you have the acceleration for A and B. Okay, so I believe that the difficult one is on this one, which is you have to determine the another 2 equation, which is coming from the length and also coming from this reaction and forces. Okay, this one I think you can understand. This one is a big difficult, or maybe it is the imagination is high, so you have to do a lot of exercise lah, to make sure that you understand and you can get some idea to solve the problems. Okay, so I think that's all for the example 2, and this is the end of the lecture 13. We don't have any lecture after this. I hope you can enjoy my lecture, and also you can understand what I'm talking about. Okay, so I hope you can you can understand what I'm drawing right now. Okay, so wish you all the best, and good luck for your final exam, and hopefully we can meet you, okay, in the future, maybe in the other subject, or maybe in the class. Okay, so thank you so very much. See you in the final exam. Good luck. Bye bye.